So improper integrals are integrals with infinite limits of integration. So if f of x is continuous on the given interval limits, then we have three scenarios where we could have the integral from a to infinity of a function, then just look at the limit as b approaches infinity of the integral from a to b of that function. So we're looking at that area from some a all the way to infinity. Or we could have negative infinity to b for our integral, and just take that as the limit as a approaches negative infinity and integral from some a to b of f of x dx. Or we could also have the integral from negative infinity to infinity of a function. So you can separate this into two functions. We have the integral from negative infinity to c of f of x dx plus the integral from c to infinity of f of x dx, where c is a real number between negative infinity and infinity. And then you can break that up as the limit as a approaches negative infinity from some a to c of f of x dx, plus the limit as b approaches infinity of the integral from c to b of f of x dx. So to evaluate the integral from 1 to infinity of dx over square root of x, we'll write that as the limit as a approaches infinity of the integral from 1 to a of x to the negative 1/2 dx. Then you can anti-derive. We have the limit as a approaches infinity of 2x to the 1/2 from 1 to a. Then replacing in the value of a and 1. And the limit as a approaches infinity of 2a to the 1/2 minus 2. And then substituting in the value of infinity, we get infinity. So this integral diverges. The area underneath that curve will become infinite. The next example, you have the integral from negative infinity to negative 1 of dx over x squared. So look at it as the limit as a approaches negative infinity of the integral from a to negative 1 of x to the negative 2 dx. So we have the limit as a approaches negative infinity, anti-deriving to get negative x to the negative 1 from a to negative 1. We have the limit as a approaches negative infinity, replacing in the value of negative 1 to get 1, and replacing in the value of a, which then becomes plus 1 over a. Substituting in the value of negative infinity, we wind up with the answer of 1. So this integral converges to the value of 1, so the area is equal to 1. Next example, we have the integral from 1 to infinity of 5x plus 6 over x squared plus 2x dx. So that's going to be then the limit as a approaches infinity of the integral from 1 to a of 5x plus 6 over x squared plus 2x dx. In order to anti-derive this, we'll have to do partial fractions. We have 5x plus 6 over x times a quantity x plus 2, which is equal to a over x plus b over x plus 2. So we have 5x plus 6 is equal to ax plus 2a plus bx. So then 5 is equal to a plus b, 6 is equal to 2a, value of a is equal to 3, and the value of b is equal to 2. So we have the limit as a approaches infinity of the integral from 1 to a of the function 3 over x plus 2 over x plus 2 dx. And then anti-deriving, we'll get the limit as a approaches infinity of 3, the natural log of the absolute value of x, plus 2, the natural log of the absolute value of x plus 2, from the value of 1 to a. Then following the fundamental theorem of calculus, replacing in the value of a and replacing in 1, we have the limit as a approaches infinity of 3 natural log of a, plus 2 natural log of a plus 2, then minus the quantity of 3 natural log of 1 plus 2 natural log of 3. And then simplifying by using log rules, we'll have the value of the natural log of a cubed times the quantity of a plus 2 squared, then minus the natural log of 3 squared. Replacing in infinity for a, the value becomes infinite, so we have infinity. Therefore, this integral diverges and the area becomes infinite. In the last example, we have the integral from 0 to infinity of the quantity of x plus 1 e to the negative x. So we write that as the limit as a approaches infinity of the integral from 0 to a of the quantity x plus 1 times e to the negative x dx. I have to integrate this by parts, so u is equal to x plus 1, du is equal to dx. dv is equal to e to the negative x dx. Anti-deriving to get v is equal to negative e to the negative x. So if the limit as a approaches infinity of the u times v from 0 to a minus the integral of 0 to a v du. So the limit as a approaches infinity, replacing in the value of a, and then subtract replacing in the value of 0. And then we're going to anti-derive the integral from 0 to a of e to the negative x dx. So if the limit as a approaches infinity, distributing to get negative a e to the negative a minus e to the negative a plus 1, and then anti-deriving e to the negative x is negative e to the negative x from 0 to a. So if the limit as a approaches infinity of negative a e to the negative a minus e to the negative a plus 1, then replacing in the value of a to get negative e to the negative a and 0 to get 1. Then combining like terms, we have the limit as a approaches infinity of negative a e to the negative a plus 2. So the limit as a approaches infinity of negative a over e to the a plus 2. That gets infinity over infinity, so by L'Hopital's rule, we have the limit as a approaches infinity of negative 1 over e to the a, which then becomes 0, so this integral converges to 0.